No problem. So we will be going to begin the session for today. All right. So Puneet, Abhas, Rakesh, I hope you all are doing well and you will be having the enough time for the batch. So I would like to appreciate this thing. So hi Rakesh, you have just joined the call. How are you?
I'm good, ma'am. Actually, I'm just traveling. That's why I'm a little bit late.
Okay. All right. Okay. No problem with that. All right. So let's begin the talk we have for today. Okay. So yesterday's session was clear to you. That is related to the STP we have discussed so far.
Yes, ma'am.
Okay. All right. So today we will be moving ahead our talk related to the port channels. Okay. And then we will be going to explore the virtual port channels in more detail part. Okay. So let me share my screen with you so that you will be getting the fair idea what I'm just talking about and how we can explore this out. I hope my screen is visible, guys.
Yes, it is visible.
Yes, ma'am.
Okay. All right. So now what is our today topic? Our today topic is again under the section number 1. Okay. That is your implementing data center switching protocols. All right. So under this section number 1, yesterday we have understood about the STP according to the data center scenario. All right. Now in our today section, we will be going to explore and have a look for the port channels. Okay. So anybody is familiar with the port channels, then please let me know. Anybody know what is it, the functionality of it? What do you understand by this term as port channels? Tell me, guys.
So, in a simple manner, port channel is a process of combining multiple physical interface into one logical interface. The
Mhm.
main purpose of the port channel is to, first of all, increase the bandwidth and
Mhm.
load balance the traffic.
Okay, perfect. Yes, yeah, that sounds perfect. And you are, I just agree with your definition, whatsoever you are telling it. That's particularly fine. What about others?
It's
Anybody would
also
like to
used
say?
to avoid the STP.
Okay, good. What else you can say?
Use the both link. If let's suppose if I am not using LSCP and I have a two switch, both are connected with using two cables. So on that time, one cable automatically blocked. So with the
Mhm.
help of LSCP, I
Mhm.
am achieving using both link and also the bandwidth, increase the bandwidth.
Increase the bandwidth part. Okay.
Yeah.
Yes, that's also perfect. So now let us explore this thing in a little bit wider way. So as this name suggested, this port channels, or we call this as aggregation of what? Aggregation of ports. Okay, either we call the port channel term or we can say it's the aggregation of ports we are doing, right? So this is the port channel. It is your one of the core technologies. First of all, you know this thing very broadly. It's one of your core technologies, okay, that where are you are going to use in the port channels. You will be going to use this port channels in the Ethernet based networks. All right, guys. So it is a core technology which we'll be going to use where in the Ethernet based networks. All right. So what this technology giving us, this port channel technology, what is we will be getting this as output, what could be the usage of it and what we are doing with it, right? So this technology that we call this as PC, port channel, This technology will be giving you, they will be going to help you to enable you to bundle multiple as I think other I think what's the name of the candidate? Abhas, maybe they said like that correct statement. So port channel enable you to bundle multiple
Physical
physical
interface.
links, yeah, multiple physical links into where? Into a single logical link. That's correct. Okay. Okay. So if we do this thing, what we get as a result, if we are doing this so, right, we will be just enabling that to bind multiple physical links together, and we'll having only one single logical link to be worked with, right? So what output, what throughput we'll get as a result? What could be the benefits we will be getting from this? Can anybody state?
High throughput,
Okay,
redundancy,
Redundancy.
good. Hmm.
avoiding STP, so there will be no loop.
Okay, good. Okay, so what could be the result for it? It will be help you to improve resiliency, and you will be able to optimize bandwidth utilization. Alright. So port channel will help you to enable like multiple, you can bind multiple physical links into the single logical link, which improves your resiliency part and will help you to optimize the bandwidth utilization accordingly. Okay. So one thing, however, in this scenario, I would like to state one more thing. However, one thing is there. We call this as classic port aggregation technology. Anybody is familiar with that? Classic port aggregation technology.
No, ma'am.
Okay. So classic port aggregation technology has a limitation actually. Okay. So what limitation does it has? What they do, they will be going to allow the aggregation of the links. They allow the aggregation of the links between the switches. Okay. In order to form what? In order to form the port channeling. In order to form the port channeling from one device to the other device. Okay, or to other different devices, you can also say. So you can use the evolution of the port channeling technology, that we call this as VPC, that is your virtual port channels. Are you getting my point? So what happened generally, this classic port aggregation technology, they have one limitation. What they do, they will be going to allow the aggregation of the links between the two switches. So to form the port channeling from one device to another device or two different devices, what you can use the evolution of this port channeling. That is, we call this as VPC. We call this as the virtual port channeling part. All right, understood up to there? Yes, guys, clear up to there?
Can you explain again, Miss?
Mm-hmm. Yeah, sure.
This
We will be going to explain you this thing again. So what happened? We have discussed about the port channel, right? It will be enable you to bundle multiple physical links into the one single logical link, right? So this will be giving us the result, like we will be have improve our resiliency part, and we will be able to optimize the bandwidth utilization. But however, there is one thing that we call this as classic port aggregation technology. It has one limitation. What limitation does it have? They allow the aggregation of links between the switches. Okay, but in order to form the port channeling from one device to the another device or two different devices, you can use the VPC, not this one. So that is why it's gonna be failed. And we have this new technology that we call the evolution, but the evolution part is from there, that is classic port aggregation technology. But now we are working on that VPCs part. That is the latest one. Understood? Clear, guys?
Okay, ma'am.
So what's the mechanism works behind VPC or port channel? Like what changed actually?
Okay. So we will be going to understand this thing about the port channel normal and the VPC in more detailed way with the help of figures. At that time, we'll get more clarity vision. But firstly, we will be going to cover the port channel. Then we will be going to cover the VPC part. Okay.
So this
Is
port
it possible?
channeling or
Mhm.
sorry,
Yes,
Abbas, you may continue.
it's okay.
No,
Tell me.
it's fine.
Yeah, tell me, guys.
So I was asking this port channel and port channeling. This is same, na? Is there any difference? Are they same
Exactly.
terms?
They are same terms, but the advanced part, the latest one, you will be working on that VPC. You are using these ones in some particular scenarios, but you are working on these ones also. So you'll able to know the difference later on once you just understand this detailing part. What could be
Okay.
the protocols we are using, control planes, additional links, bandwidth, load balancing. At that time, you'll able to consider what could be the better option for you in related to the configuration scenarios.
Okay, ma'am.
Okay. So we will be going to explore firstly the ports channel part. Then we will be going to cover the VPC. Okay. I have just give you the simple definition for it. That is why I have just add on the things there. What could be the evolution from where the VPC has been occurred. Okay. So that is classic port aggregation technology. So now we will be going to move forward. Let's talk about port channels. Okay. So when this port channels hit in our mind, right, what could be the things they are doing? So what the thing is there, like see, we have two devices, switch 1, switch 2. Okay. In both two devices, if you want to add resiliency against what? Against the link failure. Okay. In order to add the resiliency against the link failure, and if you want to increase the bandwidth between these two devices, right? How you can provision this thing? You can provision multiple physical links between the devices, right? Only then it's a way to possible. If one link is failed, you can use the another one. If another link is failed, you can use the another one. In this way you can move ahead, right? So however, if we don't have the port channel, let's say we don't have the port channel. Okay, so control plane protocols, you remember we have the control plane protocols. Can you name the control plane protocols, guys? What could be that? Tell me, guys.
STP
Right. Such
or
as STP. Yeah. Yeah, tell me what could be the other ones. There are others also. Yeah. So
NTP.
NTP is not the part there. That is the network time protocol that keep it separated. Okay. So control plane protocol, the STP or the routing protocols we can consider in this scenario. So routing protocols, you know that OSPF, let's say, okay,
BGP, AGRP,
BJP, right?
ISIS.
Right. So what happens when control plane protocols such as STP or routing protocols, OSPF, what they generally do with the links? Okay, so let's explore this thing. When what they do with the links, they will be going to treat the link as individual link. Okay. So in the case of STP, if we look into, okay, the process result to what? Blocked ports. Only then the communication will be possible. They will be going to block one port and then they rely on something and then they can transfer the data according to your demands and needs, right? So these two protocols, like control plane and routing protocol, they treat links as an individual links. So in the STP scenario, this process result into the block ports. If you, although if you the additional links had added, okay, so additional links had been added there. So if the additional links has been added, then it's gonna be improve your resiliency part and the bandwidth scenarios. But again, there is one scenario, the bandwidth between the two devices is not gonna be fully utilized. Okay. So in the case of routing protocols, this thing I'm talking about in the case of STP. Now let us explore in terms of routing protocols. Okay. So in the terms of routing protocols, like OSPF, what how they are going to treat that particular link. In the terms of routing protocols, the routing protocol, they are open to use the additional link. Why they use the additional link? In order to balance the load. So load balancing they can perform. That is why they can go with the additional linking part. Okay. But this process, however, also require a routing adjacency to form for every link, which increases the routing protocol overhead again. Okay. So these both protocols, the STP control plane protocol and the routing protocol, that is OSPF, okay, they treat the port channel. They both things, they will be going to treat the port channel, this particular port channel, as a single link. Okay. So spanning tree will not block the links that are part of the port channel, and the routing protocols also will only form a single routing adjacency across the port channel. So the main summarization of this whole thing, they will be going to treat that port channel link as a single link. They are going to treat the control plane protocols and the routing protocols. Okay. So now, when we talk about the traffic, let's say the traffic is there. Traffic that is switched, either the traffic is going to be switched or routed. Okay. So when the traffic is that is switched or routed to a port channel interface, at that moment what is going to be happen? Traffic is switched either or routed, either it's traffic is switched or routed, okay, to a port channel interface that is balanced across individual physical links. Okay. So there is one mechanism in which you can do, I think you are familiar with that, that we call this as hashing mechanism. Okay. So what hashing mechanism is doing there? They will be going to this hashing mechanism. They uses a configurable selection of what? Selection of fields in the packet header. Okay. So hashing mechanisms, they uses the configurable selection of the field in the packet header. They choose accordingly. Okay. As well as what? As input. Okay. So for example, let's say you can choose to balance the loads across the link. Okay, so there are several links and you have to choose the load across these links. Okay, how you can do that? By checking what? Tell me how you can balance the load. What you can check? What you can check if you want to
I
balance the
believe
load?
in the port channel we can do this. By default, it will basically take source and destination map. Like,
But yeah, perfect. So how you can check that? By destination MAC address. Okay, or the source and destination. So with that, one thing I would like to add on, like you are telling me it's a source and destination address, that is fine. But here you can look for the source or destination TCP port numbers.
There is lots of algorithms, plus
Yeah.
maybe the nine, more than
Yes.
nine.
Yes. Yes. There are more than algorithms. Right. Right. Okay. So understood up to there, guys, about the hashing mechanism for the same.
yes, ma'am.
Okay. So now I will be going to frame this thing with the help of one representation. So you will be more comfortable with that, what we are just doing there. All right. So let's explore this thing. So see, we have this representation. Okay. So what you are observing in this representation, there are three circles, layer 3, layer 2, right? Okay. So what this figure is explaining to you that port channel links is used to connect several switches, right? First of all, let's look for this figure and check out the detailing for it. Sorry. So the port channel links are there, okay, and they are used to connect several switches. Okay, so you can see the connectivity, it's there, right? So port channels links are used in order to connect several switches together, right? And along with that, the pair of ports, the pair of ports are also used in order to create what? In order to create the port channel bundles. All right. So what? Because what happens generally? Because a switch detect each port channel as a one logical connection, which we have just understood from the beginning itself. Like what we have understood, like a switch is going to detect each port channel as a one logical connection. Okay. So the switch is able to use both the ports of each port channel link at the same time. Okay, so which you are also seeing in this representation. Okay, so port channel benefits, what benefits we'll get if we just perform this port channel configurations and all. Okay, so benefits what we'll get as return with the following. Okay, so let's illustrate. So see what benefits we'll get. The first benefit we'll get the optimized bandwidth usage. Okay, we have the improved network convergence. And the third point you all know. Tell me what could be the third point, what benefit we'll get? Tell me, guys.
Redundancy.
Redundancy?
Yes, that is fine. But what could be the main benefit when we look into the port channels?
Load balancing.
No.
In,
Bandwidth.
the, in this scenario, port channel, sorry, STP not work. It's
Perfect. So spanning tree mitigation. This is the benefit of it, okay? You have already told me in the starting, right, Rakesh?
correct, ma'am.
Yeah, so that is the benefit of it, okay? After that, there will be resiliency also against what? Against the physical links that is failed. Physical link failures. All right. So this is the detailing about the same. Now we will be going to explore the port channel physical as well as the logical view, how it's gonna be look like. And this time I would like to tell you about the series of the switches also. Okay. So let's explore this thing in detail
Ma'am,
part. So
before move, can you just let me know if let's suppose the traffic is coming from switch one, okay,
okay.
and switch one and switch two, I have created one port channel.
Mm-hmm.
How my packet will decide which interface or
Mm-hmm.
which algorithm it will use? It will use it will, that packet will be used as a load balancing, or how goes? Can you just little bit
Yeah,
explain in the
I will be framing that scenario now. That
okay.
scenario just I'm going to cover. So for that, we'll do with this help of image C. Okay. So
One more
what you
thing
are,
here.
yeah, tell
Uh,
me.
how this switch come to know that this link as a port channel? Anyway, it is logically yes, it is a port channel, but physically there are four links to three links. So when the switch receive the packet, it will broadcast. So
Mhm.
why the traffic doesn't go back to the physical link again?
Mhm. Mhm. Now I will be going to frame this scenario. Now just you're able to understand what I'm just going through. Have a look at for. See, you are observing on the screen we have the physical view and the logical view. Okay. This figure illustrates you about the port channel physical as well as logical view. In the physical view, multiple ports are defined as being the part of ether channel group, whereas in the logical view, subsystems running on that switch see only one logical link as per the ether channel because they bundle up the link, right? So now your question is there, right? So I would like to tell you one thing. Cisco Nexus switch. Okay. Cisco Nexus series switches, we can talk about the Nexus series switches. They support what? Bundling of interfaces into a port channel. This series of switches is gonna be supported. Okay. Now you have framed one question, what could be the ratio, what could be the number for it? Okay. So maximum number of ports in a channel, that is depends on what? That is going to be depends on what exact switch hardware and software combination, that is rely on that part. Okay. So for example, let's take an example so that it will be more clear to you. We have Cisco 9000 series switches. Let's talk about this. Okay. So we have this series of switches, and in that series of switches, according to their hardware and physical combination requirements, they can bundle up to only 32 active links. 32 active links into the port channel. Okay. And on the Cisco Nexus 9000 series platform, port channels can be configured on the layer 2 or the layer 3 interfaces. Understood up to there? What your question and what could be the answer for it?
I have one query. In 32, how 32 port will active? Because LSCP, PAGP, and static, these protocols has a limitation. Let's
Right.
suppose in LSCP, only the 8 port will be active. If I am bundling 16 ports, but active and 8 is passive.
That's the answer for this question would be your channel modes. We will be working with LACP also, port channels, and LACP is our next topic. And in that, I will be explaining you the channel modes, the passive, active, and on. In that part, you will able to know how many are in the active state they can use, how many are in the passive state which you can use according to that.
Ma'am, that depends on the Nexus hardware, like M1 card or F3 card, F2 card. So I guess if we have
Plus,
F
yeah,
series,
plus
so
they
it
will be
can.
also yeah, plus they will be also rely on the modes also, LACP modes, active, passive, on states that are compatible or not. Okay, so that is also the part with it.
So in general, it means if I have a active mode, so
Mhm.
it will be 30 ports, 32 ports will be active at the time.
See, we can't frame this say only 32 ports. Like you have to like give some interface type slot, then port number, then you can allocate these things. Like there are certain commands for it. You cannot
Okay.
specifically make marking all as on one, okay, because you don't require all the ports in the one go, right? So you have to select the interface type slot and then specific port number. Then you are going to channel the group with the name mode. Either you want this as active, you want in the on state, or you want in the passive state. Getting it?
So,
So you will be understood. You will be able to clear when we understood the port channels and LACP topic. At that time, we'll able to get more familiar with it. Okay.
so that means 32 active links can be load balance the traffic. Is that so?
Yeah, that's
Means
load balance the traffic. Yeah. And other than that, it is only with the which I'm just framing the example is the 9000 series, which is example. Okay, I'm not taking the other hardware to frame one example it to you, right? Because maximum number of ports in a channel depend on exact switch hardware and software combination. So
correct.
whatsoever device you are using, it depends accordingly and it vary accordingly also.
Then one more thing, like
Mhm.
how means as you said that we will
Mhm.
channel this. Means let's say we have a 32 active links, we will bundle up. And how can we use it as L2 and L3 interfaces? I haven't, means this is not clear to me.
Yeah, we will be going to cover these two things with the LACP.
Okay.
Okay, so LACP in this when you will be able to more clear how you can frame this thing.
Uh, One quick question.
Yes.
In case if we have a 10 GB of packet, okay, will it
Mm-hmm.
do the load balance or load sharing? I mean, like if we have four lanes,
Mm-hmm.
the traffic will be a travel across the four lanes or just one link.
See, it depends on the hardware. What could be the requirement they will be giving you in the terms of packets. If the software and hardware requirement is there, they can frame the links in a one go. They will go. Otherwise, they will be have to separate it that link and then they have to separate it and then merge them in a four separate links in order to balance the load. It vary accordingly actually, according to the hardware and software requirements of that particular device, whichever you are using it.
I think you can also see it like if you have a physical port, you have bundled 10 physical ports.
Right.
However, if they all are a 1 gig port, so definitely they will do the load balance.
Right.
You can also do, I think there is a command called
Yes,
show ether
show it.
channel load balance. So
Mm-hmm.
most of the hardware, as ma'am said, so some hardware support source and destination IP, and some hardware do based on source and destination MAC. So they basically create a table based upon the bundle of the port you have.
Both channels,
So
right.
yeah. So accordingly, they do the load balancing, and you can change it also.
Yeah, it you can manually configure it also, but for
Correct.
that you have to specifically mention the modes also, active, passive, on, which you want to make it as the going one, right? And then you have to select the interface. So all configuration, if you done under the channel group, only then it will be possible. Okay.
Is it doable in the catalyst switches? I mean, we can control the load balance.
Yeah, actually, to be very honest, I don't have the clarity vision with the catalyst switches, because with that topic, I have the clarity vision for the 9000 series switches. So for that, I
You
can
can do
guide
it
you. Okay. So
in the
you can check,
catalyst. You
or
can do it.
otherwise I just check, like I just check by my own tomorrow. From for the next weekend, either you can check the detailing in the Cisco website. They all will be giving you the detailing. What could be the specifications for that particular switch? So you can check all the detailing there. With that particular model, you have to type. You have to click to the specifications part. You will able to know what could be they are providing it to you, which device. All right.
Okay,
So
thank you.
okay. Welcome. So shall we move forward with the LACP and port channels now, guys?
Yes, ma'am.
So now we have discussed so far about the detailing related to the port channels. Now we will be going to explore the port channels and LACP. Okay. So how many of you are familiar with the LACP, guys? Yes. Anybody knows what is LACP?
So in LACP stands for Link Aggregation Control Protocol.
Perfect.
So generally, port landing can be done in three ways, either using LACP protocol and PAGP protocol, or you can use it manually.
Mhm.
So they are the two protocols through you can do the port channeling. In
No,
LACP, we have, I think, two modes, which is active and passive.
that's it.
PAGP, we have a desirable and auto. LACP is a open standard. PAGP is proprietary. This
Right.
is what I know.
Yeah, that's perfect. Okay. So yes, you are right there. So let's explore this topic in detail in terms of the data center scenario. So like you can create a port channel, okay, but how you can create the port channel at that moment, your default channel mode is set to on. Okay. So in this way, you can create the port channel. Okay. Which defines what? Which defines that it is a static port channel. Okay. So let us understand the Cisco Nexus part. So we will be using the Cisco Nexus series switches. Okay. So in that Cisco Nexus series switches, they will be going to support LACP. So what is LACP? That is your link aggregation control protocol, right? And what does it do? They will be going to use for negotiating the link, binding. Now, so one thing I would like to tell you that LACP packets, LAC packets are exchanged where between the ports. Okay. And these ports where they are in, either they are in the active state, active mode, sorry, or passive. So when they are in the active or passive mode, LAC packets are exchanged between the ports. Okay. So both modes, like this active as well as passive, these both modes, they allow LACP to negotiate between the ports. Why they negotiate between the ports? In order to determine one thing. If they can form a port channel. Okay. So once the negotiation is successful, okay, once the negotiation is successful, at that moment, based on the criteria, what could be the criteria in order to make this negotiation as successful? The criteria would be yours. They will be going to check the port speed as well as the trunking state. Okay. So one thing I would like to highlight there, the passive mode is useful. Passive mode is useful. Why? Because when you don't want to, when you do not know whether a remote system, or a partner supporting LACP or no. So at that moment, I must say the passive mode is really very useful for you. Okay. So let us understand with the help of summarization related to one table with the port description. Okay. So we have just check out the detailing. Now see, we have the channel modes and we have the port description for it. So let's talk about first mode, that is your passive mode in LACP. Anybody is having the idea, if the passive mode in LACP is there, what could be the port description for it? Yes, guys.
No, ma'am.
Okay. So if the channel mode is in the passive state, at that moment the port description would be your, they will be going to respond to LACP packets that it is received. Okay. But it does not initiate the LACP negotiation in this stage. Okay. Now, the second one would be your channel mode, that is in the active state, LACP. So anybody having idea what could be the port description at that moment? What they do?
It will send the
It will
LSCP
initiate.
packet. It will
But
initiate the, just generally
yes,
you
yes,
can say the
yes, yes.
initiate.
Yeah, it initiate, first of all, what? It initiate the negotiations, right? With what? With other ports. Okay, by sending the LACP packets. That's perfect. Okay. Now there is one more channel mode. If you know, that is on. So what they do in the on scenario? Can anybody state?
It does not send anything. Okay,
Mhm.
it just sends self. I am now going in LSCP. I
Uh-huh.
think
Yeah, that's fine. What else they do?
they always
Mhm.
active
Mhm.
if my peer link is connect in my peer device, or maybe the peer port is active or not, or maybe the LSCP or ether channel is not, but I am always performing
Mm,
as a LSCP.
not exactly we can say like this way, but yes, let me frame the first point of your Rakesh is correct. Okay, so it gonna does not, it's gonna be send any LACP packets. Okay, Furthermore, it does not join any LACP channel group also. And the third point is also there. What they do, sorry, they'll become the individual link with that particular interface. They'll become the individual link with that particular interface. Okay. So here we have discussed about the channel mode along with the port description. Now you know we have the ports that can form the LACP port channel, but they are in the different LACP mode. So as long as the modes are compatible, then you can describe the following table. So let's say we have the three modes, right? Which we have discussed so far. That is your passive, active, and on. Okay. So we can frame there also passive, active, on. Okay. So ports can form a LACP port channel when they are in the different LACP modes. So as long as the modes are compatible, you can able to see the detailing with the following table. Okay. So passive, no. Passive active, yes. Passive on, no. Active passive, yes. Active, yes. Active on, no. On passive with no.
No.
On active, tell me.
No. No.
No, right? And on with
Yes.
yes. So in this way, they are going to operate it. Okay.
Ma'am, I
Understood
have
up
one
to there?
query in
Mhm.
LSCP. In LSCP packet, which kind of information it's carry?
Okay. So if like say LECP feature is disabled by default. You
Mm-hmm.
first know this thing, okay? So you have to make enable LACP before you want to begin LACP configuration. Okay. So once you enable the LACP, you can configure the channel modes for the individual link.
Okay.
Okay. So in the LACP port, whether the channel is in the active state or passive state, okay, the channel configuration you want to allow the link to operate with LACP. So these things you can do if you want to configure the interface to enable the LACP in the port channel, that you can do. So with these things you are using this port.
Ma'am, if you have a if you have a PK file kind of logs, so if you can show us.
Yeah, I will be sharing with you. Like, I don't have any files or something. I have my like this kind of note in a rough way, so that I just am going to deliver for the same. But yeah, if you required something, I'll give you some specific detailing. If you need for some topic, I'll give you that one also.
Okay.
Okay.
Um, One more
Mm-hmm.
thing. We have come across one issue where we were using active passive setup. I mean the active passive mode between the switches, and the link was not coming. I'm not
Okay.
sure what was causing the issue, but the configuration wise, everything was fine. Then we
Okay.
changed it to the on mode, and the link was up and working. But can
Okay.
you just
Okay.
explain like what could be the
Yes.
reason
Yes.
and
Yes. Yes. So, firstly, you tell me which command you have used for the same. You know the command?
I don't exactly remember the command, but I can check this thingy.
Okay, if you know the command, you can share, then I'll guide you. Rest, I can guide you the command, which could be the correct one. In that, if you use this command, it's gonna be worked. Okay,
No, it
so
was working actually. The things was working, but all of a sudden when the switch was
yeah, the
restarted,
group mode you are just
yeah,
talking about active on passive. So what
yes,
could yeah? So if you want to configure, so if you want to configure an interface to be the port channel, okay. So at that moment, what could be the particular command? First of all, you have to write feature LACP. Okay, then interface you have to select interface. What could be the type, slot, port numbers, okay, and then you have to hit the channel group, okay, with the number, and then mode you have to select accordingly. The three modes are available: active, on, or passive. So if you hit this command, your configuration will definitely work according to my knowledge. Okay. So the number in the channel group command specifies the port channel in which this interface is associated. And when you run the port channels with no configured protocol, so by default they will be configured this mode as on one. So that is why maybe you are facing this challenge.
Ma'am, one more thing.
Mm-hmm.
In this configuration, let's suppose you have enabled the feature.
Mm-hmm.
After that, you will configure port channel. Let's suppose the interface port channel 1, and now you can configure trunk port. Okay. Now
Mm-hmm.
I'm in this port channel, I'm adding port now interface ETH something like. So
Mm-hmm.
on inside the interface now there is one specific command port
Mm-hmm.
channel group number. Let's suppose the port channel number is 1. After that, there is one command force,
Okay.
then
Mm-hmm.
mode, and then active or your passive or on depending on your configuration.
Mm-hmm.
But this command only works when you configure port channel
Mm-hmm.
before assigning the interface. That command I have recently seen this the release after upgrade 10.x. These are models now, these OS will support this command.
Okay. So, LACP generally, when we look with the LACP, it is a part of IEEE, that
Correct,
is
ma'am.
8021 AX, right? Specification we have it for, right? So because LACP is a IEEE standard, so you can use it to facilitate the port channels in the mixed switch environment, right? So in order to check the configuration consistency and manage the links, additions, failures between the switches, so my suggestion, you can ensure that you are creating a port channel and where all the ports having the same type of configuration with duplex setting and VLAN information. So any port modification after the creation of the channel you'll do, you have to make the channel changes on other channel ports also.
Is there any way we can enable the debug for this specific configuration to see
Yeah,
what
so
parameters they are
see, you can create the port channels with the all ports. You have to give the same type of configuration, speed, duplex setting, and VLAN information. So with that, I think that's gonna be work.
but if we want to enable the debug, so what will be the debug command?
So for specifically the debug commands, I must say you have to run the full detailing for it. First of all, then you are able to see the debugging. You just simply add the debug there.
No, but there's any command just to get the output for the port channel only, because I can't use the debug all, correct?
Yeah,
You
you
are only
can't.
see the LACP debug, correct?
Yeah, with the LSCP debug we
Yeah,
can.
there is one, there is lots of command, ma'am.
Actually, that is why I'm also thinking the same. What could be the perfect I will suggest it for? So for the debug part, you just ignore that part, I must say, because according to your syllabus and criteria, you will be having only the configuration for an interface with the featuring part of LACP. After that, you will be having the virtual port channels detailing. You should know about the modes. You should know about the how the port channels overview working criteria is there. So according to your scenarios, you will be having this information as it goes.
No, I understand. I agree with you. The configuration wise, we will look for it. But I'm looking for the troubleshooting perspective as well.
Yeah, so if you're looking for the troubleshooting, so Rakesh, can you guide? I think you have more exposure on it. What could be the perfect command? Like if the candidate is wondering for the
Uh,
debug one, what you can suggest?
there is one command debug LACP all. And if you want to specify the packet or event or error, there is also a specific commands. I'll just share in chat. Just give me 1 minute.
So you can have a look. If you are able to run this out, then it's fine. Okay. Either you can have a conversation with Rakesh, what he's telling. if you want to debug something for it. All right.
These are
Yes.
the commands for a specific
Oh,
LSCP.
so Rakesh has ping in the chat. You just check. Puneet is
Well, I'll
wondering,
check
or
it.
Abhas? Abhas, you just check it once. That is,
Sure.
either you can use the debug LACP all, debug LACP packets, events, or errors. So you can just have these look as accordingly. Okay. Okay. So we have covered so far about the detailing that is related to the port channels overview. Okay. So now we will be going to explore the VPC detailed. Okay. So let's explore the VPC now. So anybody knows about the VPC? So I'm happy to assist. Like if you can share your information related to VPC to me.
Like it is one of the port channel feature, which gives you two different chassis on other two different device on other on one side and one single device on the other side. Or like traditional port channel will is gives you a link level redundancy. VPC gives you a link plus device level redundancy. So there are like different terms used by VPC uh, for syncing between the two devices on one side.
Okay. What about others? What are your opinions on it?
It's provide high performance, redundancy,
Mm-hmm.
scalability. These
Okay. All right. So let's explore this thing in dig deeper way. Okay. So what is VPC? Let us explore. Like you have understood about the port channels. Okay. So when we are talking about the port channels, we have to bind something, right? The picture that's come in our mind, like port channel, enable you, enable you to what? Enable you to aggregate the things, right? Enable you to aggregate. We call this as term as bond, multiple interfaces together. Okay, like this way. So that why they have bind this thing in order to balance the load or while the traffic is load balanced across these physical links. Okay. So still the problem is that all links in the port channel must be connected to a same switch. Okay. So what happened that all port channels, there's one problem that all links in the port channel. Wait, one moment. So what could be the scenario? Is that still there is one problem for it. So still the problem is that all the links in the port channel must be connected to the same switch. Okay. So when the port
Why
channel is, yes,
why it need to be connected to the same switch?
I'm just explaining that one now. So when the port channel is established between the two pair of switches, when the port channel is established between the two pair of switches in the modern data center networks, when we are looking into the modern data center networks, okay, so here a switch, router, computing node can be connected to the two different switches, which cannot be done with the traditional port channels. Understood? So what happened in the modern data centers? A switch, a router, or a computing node can be connected to two different switches, okay, which cannot be done, this thing cannot be done previously with the traditional port channels. This thing is not be possible with the traditional port channels, okay. So what we have the virtual port channels there as a solution, right? So virtual port channels, okay. So virtual port channels, what they do, a pair of Cisco Nexus switches, okay, a pair of Cisco Nexus switches that you can use as VPC to present themselves to other network devices, okay. They will be going to represent what? A pair of Cisco Nexus switches, they can use the VPC in order to present themselves to the other network devices. What? To other network devices, what they just suggest is for? Tell me, guys, what they represent that VPC to the other network devices. Tell me,
Single switch.
as a single logical layer 2 switch. Okay. So, however, the two switches, they remain as two separately managed switches with the independent. So, they will be going to represent this as they will be independent to each other, independent to separately managed switches, and they will be having independent management and control planes. Okay. So when we are looking into the VPC architecture, so VPC architecture includes what? They will be include the modifications, the modifications to what? The modifications to the data plane of the switches. Why they have performed the modification? Anybody can tell me the reason why we have why we have performed the modifications to that VPC architecture, the data plane of the switches part, in order to ensure what? Tell me, guys. Anybody is having the idea for this? Yes.
Redundancy across two switches,
No.
so data can flow.
No, we can't say this way. Yeah, data, you are somewhat relating, you are somewhat close to the answer. Please relate it more. Anybody can state? Yes. Anybody knows the specific reason why we have performed the modifications in the data plane of switches?
Oh, ma'am.
Okay. So let me disclose the answer. So in order to ensure the optimal packet forwarding, okay. So VPC architecture also includes two more plane, the control plane. Okay. So VPC architecture includes the control plane components in order to what? in order to exchange the state information. State information about what? Between the switches. Okay, and that will be going to allow the two switches to appear as a single logical layer 2 switch to the downstream devices. All right. So now let us explore what could be the control plane purpose for it and what is that one in detail part. So let us explore this architecture in the deeper way so that you will be more familiar and capable. What could be that one? So let's explore this thing. So see, you have this representation, okay? And in this representation, what you are observing, guys, tell me.
Two cables are directly connected, but one cable, or you can say keep alive cable,
Mhm,
are connected via L3 device or maybe the routing.
mhm. Okay, what about others? What are your opinions on it? Yes, guys, tell me.
And one more thing,
Mhm,
we have a for the LSCP,
mhm,
we have a two separate link for
mhm,
switch 1 and switch 2. But in
mhm,
my access switch, you can consider as access switch or distribution switch.
mhm.
It will treat as a LSCP.
Yeah, we can say like this way also. What about others? Instead of Rakesh, anybody would like to frame something according to the picture? What do you know accordingly?
So according to the picture, that down we have one access switch, and above we have two switches, which which is forming a port channel with with the down access switch. But this port channel, like they have interconnectivity between them, so that they can exchange the control messages. And to the neighbor device, it will be looking as a single switch.
Okay. Any other one?
The VPC is configured on the access side, and we have a core switch or
Mm-hmm.
core layer. We can say. Yeah. There we have two switches acting as a VPC
Mm-hmm.
connected to check the availability of each switches using the VPC PNL.
Okay. All right. Okay. So when we are talking about the control plane, for the control plane purposes, okay, the two VPC pair switches. So you can see this is the VPC pair switch and this is the VPC pair switches. Okay. So two VPC pair switches, they will be going to represent themselves as a single logical switch, right? As you can see in the figure also, right, guys? So these two VPC switches, they will be going to represent themselves as a single logical switch to which? To the layer 2 domain. Okay. When you have the LACP there, so for LACP, this appearance is accomplished by generating the LACP system ID. Where you can get the system ID? Tell me, guys. Anybody knows?
MAC address.
Right. Only not only the MAC address from the reserved pool of MAC addresses.
Okay.
Okay. So from the reserved pool of MAC addresses, okay, which is then combined with the VPC domain ID. Okay, which is combined with what? Which is then combined with the VPC domain ID. Alright, so if the downstream device in the VPC did not see a single device, okay, so let's say if the downstream device if the downstream device in the VPC does not see single device on the okay, remote end of the port channel. So what the port channel will form? Will it able to form the port channel or not? Tell me guys, will the port channel will form? If the downstream device in the VPC they'll not able to see the single device on the remote end of the port channel, then the port channel will be formed or not? Tell me guys if you know.
I think no, ma'am.
No, the port channel will be not formed. Okay. So for STP, VPC primary switch, VPC primary switch is responsible for what? It is responsible for generating and processing BPDUs. Okay. So that in for STP, the VPC primary switch is able to generate and processing the BPDUs. Okay. And uses what? They will be going to use its own bridge ID for the BPDUs also. Okay. So when you have the VPC secondary switch, okay, so you can say this is the primary switch, this is the secondary switch. Okay. So when the VPC secondary switch is there, that secondary switch will relay on the BPDU messages but not generate itself BPDU for the VPCs. So while doing this, so while framing the whole scenario there, VPC will be giving us a lot of benefits. Okay. So what could be the benefits for it? Let's explore the VPC benefits. Can anybody tell me the benefits for VPC? Anybody know any of the one? Benefits for the VPC. Let's talk about this.
The first is hardware redundancy.
Hardware redundancy. We can say, what else we can say? Like you are very close to the term, Rakesh. The hardware redundancy is there, but try to reframe it.
Scalability.
Yes, we can say scalability, but let's give the benefit as it will be going to provide fast convergence.
Okay.
Okay, if either the link or device fails. Okay, let's frame this thing as this. This is the benefit of it. What else? What could be the other benefits? Anybody would like to state? Yes, guys. So if we look this VPC in terms of STP, what we benefit will get? Tell me.
Loop free.
Loop free, yeah, it is loop free, but how loop free? What could be the perfect benefit? You can
It's
describe
a
it so.
logical one device. So
Mhm.
the link will consider as one link. I mean, the multiple links will be considered as one link, so there will be no any loop.
Okay. So yes, so they will be going to provide you what? They will be going to provide you a loop free topology. Perfect. Okay. What else? It will be going to eliminate also STP blocked ports. Okay. What else? What they will provide you? What benefit you will get with the VPCs?
Two management plan.
Okay. They will be going to help you to ensure high availability also. What else?
Bandwidth optimization. It will be acting as active.
Mhm. Okay. So you can see that uses all available uplink bandwidth. So we can say this is also the benefit of it. So one thing it's also there, they will be allow a single device to use a port channel across the two upstream devices. All right, guys. So this is the detailing related to the benefits that is related to the VPC. Now, one thing you can also observe in this representation, we will be having two switches there, which we call this primary and secondary part. So let us explore this thing also, so that you can get the fair idea on it. So let's say, so you can see between the pair of what? Between the pair of VPC peer switches. Let's say this is the switch and this is also the switch. Okay. So what could be there? There is one election. Okay. So an election is held to determine what? To determine the primary and secondary VPC device. Okay. So this election is not primitive. Okay. So VPC role there in order to determine there. So VPC role there in order to determine what? In order to determine the two switches is responsible for generating and processing of the VPDs. Generating and processing. Okay. Other than that, this election also control that VPC operation in failure scenarios. So this election has to be done in order to know which is the secondary switch or which is the primary switch. Okay. Now, when we talk about the roles of it, so let's say when we are talking about the roles, so this is our primary switch. So primary switch role. So primary and secondary roles determine how. Can anybody state how they can determine the scenario there? So primary switch and secondary roles, how they can determine?
They can determine by priority.
TR role also.
Yes. So priority, TR roles, whatsoever you can say, we can summarize them as behavior, right? Right. So primary and secondary roles determine the behavior of VPC peer switches. where in the certain failure scenarios, so mostly if there is a peer link failure, okay, so let's say this representation is the peer link, this is the failure, okay, then the VPC primary switch determines what? Tell me guys, what they are going to determine? If this
Primary will be
link
the
is
primary.
there, yeah, the left one I consider this as a primary and this I have considered as a secondary. So what I'm saying, see, if this VPC peer link between these two switches has been failed, okay, so what the VPC primary switch determine, what they have to do at that moment?
At that moment, he will check keep alive link if is
Perfect.
connected or not.
Perfect, right. So they will be going to look after what? Through the through the keep alive peer link. Okay. So what could be the scenario? If the peer link is gonna be failed, then the VPC peer link fail, then the VPC primary switch determines through the peer keep alive link, that is this one. Okay. And if VPC secondary pair switch is still operational, like it is in the working condition or it is operational, doing some work, okay, then the VPC secondary pair switch is operational, then the primary switch instructs the secondary switch to suspend the task, to suspend all the VPC member ports they have it for. Okay, so what could we are getting as a result if we have this scenario? So because of that we will be getting the result that secondary switch also shut down. Okay, all the switch virtual interfaces, which we call this as SVI, that are associated with any of the VLANs that are allowed on the VPC peer link. So that is the part for the VPC peer link there. Okay, so here itself, I would like to summarize, like you know about some fabric services. Anybody knows about the Cisco fabric services? What is it? Yes, guys, you know
It
about
is
it?
a protocol used to sync the data between between both the peer switches. Uh,
Mhm.
so Cisco Fabric Services was earlier first used in MDS switch, and then the concept came into Cisco Nexus switches. So they basically sync the ARP table, they sync the IGMP, they sync the like uh,
Mhm.
the
Okay.
protocol that need to be synced. So basically,
Roles
it is
also.
used
Roles also there.
election process.
Mhm. Okay. So Cisco fabric services over the Ethernet, when we look into that scenario, it is a primary control plane protocol over the VPC peer link. Okay. What it do at that moment? So what they do, they will be going to perform several functions. So as you are telling me a lot of functions there, right? But let me summarize according to the topic. What could be the functions they are going to perform at that spot of time? First of all, they will be going to synchronize MAC table entries. Then they will be going to synchronize IGMP snooping entries. Then they will be going to what? They will be going to track, if that link is going to be failed, they will be going to track the VPC status on that peer, and they will be also going to synchronize the ARP tables for the layer 3 for the VPC peers. Okay, so this fabric services over the internet, they will be going to perform these several functions if this thing gonna be happen at that moment of time. All right, up to there it's clear, guys. Now we will be going to explore something in detail. Okay, so we have just looked for this figure that is related to the simple description of it. Now we will be going to explore about the VPC components in a more detailed way so that you can get the fair idea on it and you will be not able to forget the VPC the rest of the life. So like see, are you able to see the figure there on the screen, guys? The same figure I have explained with the more detailing. Are you able to see, guys?
Yes.
Okay. So you can see this VPC architecture consists of these components. Like what could be the components you are observing? VPC peer, VPC peer link, right? Cisco fabric services, VPC peer keep alive link is there, VPC domain, member port, orphan device, orphan port, right? So these are there, right? Are you able to see them all, right? So now let us explore this thing and what we call this as for. So the whole thing you are framing on the screen, that we call this as building blocks. That are the building blocks of VPC. Okay, these all are the ones. Now, what happened generally? Let us explore this architecture in detailed way. See, so a pair of Nexus switches that use VPC to present themselves as a single logical layer 2 switch, you already know, right? So two switches, these two switches remain separately managed switches with independent management and control planes. Second point. The third point which we have stated, like they need to modify to the data plane of the switches so that they can optimal the packet forwarding part, right? In order to exchange the information to the downstream devices. Now we have this components there. Let's first talk about this VPC pair. So what does VPC pair in it? Can you tell me what does it do in the VPC architecture? Yes, guys. Yes, guys. Tell me. Anybody know? It's Rakesh, Shabhas, Sunil. Do you know?
Regarding VPC peer,
Yeah, VPC peer. I'm talking about this thing, VPC peer. According to that representation, what you are understanding of VPC peer?
VPC PM is like one of the switch. We can
Mhm.
call it as a VPC peer out of two. So the left side is the one VPC peer, and the right side is the second VPC peer switch.
Okay,
So which is part of a VPC domain. Uh,
okay,
yeah.
okay, okay, perfect. So yes, let me explore this thing. So VPC peer, this is your core of the VPC architecture, and it is a pair of the Cisco Nexus switches. So this pair of switches will be going to act as a what? Single logical switch. Okay. Now, our second thing, that is your peer link. What this peer link is doing? This peer link I'm talking about. So this peer link, they will be going to carry the control traffic between the peers. Okay. So this peer link is also very important connectivity element in the VPC system, because the link is used to create the illusion of the single control plane by what? By forwarding the BPDUs, okay, and the LACP packets to the primary VPC switch from the secondary VPC switch. All right. So this peer link is used to synchronize your MAC address tables, IGMP entries, snooping, ARP, right? And when this VPC device is a layer 3 switch, at that moment this peer link also carries HSRP packets. That is your host standby router protocol packets. Okay, this is the peer linking. After that, you will be having the detailing for the VPC keep alive link. So this one, I'm talking about this one now, the VPC keep alive link. What is it doing there? So VPC keep alive link, they will be going to routed the link carrying the heartbeat packets for active to active detection. What else it's doing? So you know it is a logical link first of all. It is a logical link that often run over the out of band network. Okay. So this peer link provides the layer 3 communication path. VPC uses the second test to determine that remote pair is operating properly or not, which we have just discussed. Like it is in the operation mode, then they are going to tell that this is the backup scenario. You just have to suspend all the member ports which you have created with the keep alive link, right? So in this scenario, the VPC switch to determine which keep link itself has been failed or whether the VPC pair has failed entirely. So this will be giving you information that is related to it. Now you have the VPC, this one as this circle. So this VPC, what they are doing, they will be going to combine the port channels between the VPC pairs and a VPC capable downstream. So how you can frame this thing? So this VPC there itself, it's a multi-chassis ether channel. We call this as MEC also as a short form. So it's a multi-chassis ether channel. Okay, and it is a layer 2 port channel also. We can call this as what they do. They will be going to span the two switches, right? So they will be going to span the two switches. So the downstream devices, so these downstream devices is connected to the VPCs so that they can see this VPC peer switch as a single logical switch because they have combined this out and they will be going to represent this as a single logical switch. Okay. Now you will be having the domain, VPC domain there. Okay. So in the VPC domain, you will be including both the peer devices, this one and this one. All right. And along with the keep alive link. So VPC link all the port channels in the VPC domain that are connected to the downstream devices. So you have to identify with the domain ID in the VPC. So if you have, you can only have one VPC domain ID on each device. Okay, in that network. Then you will be having one member port there, that is your VPC member port. So what is the member port? The port on one of the VPC peers, that is the member of one of the VPC that is configured as the VPC peers. So one of the all ports that form a VPC, that is your member port. Then you will be having one orphan port there and orphan device also. So with the orphan port, what is it? So term orphan means like it's a switch port actually. So orphan port will be refers to as a switch port that you are connected to the orphan device. So this is the orphan device and this is the switch port that you are connected with. All right. So the term often refers to a switch port that you are connected to the orphan device. So this term also means that VPC ports who are the members that are connected to a single VPC pair. So in this situation, if the device you are connected to the VPC loses its connection, then it's going to be considered one of the VPC pairs. All right. So with that, you can configure the VPC on the Nexus switches. So that's all about the detailing for it that is related to the VPC and the port channels overview. So from here itself, your section 1 is completed from my end. Okay. Section 1 is completed. So after this session you will be having the session on the next weekend, right? So in the next weekend you will be going to explore the section number 2. So section number 2 is all related to the first hop redundancy protocol. You will be going to explore the second topic of ours. So we will be starting from the next weekend, that is your section number 2. All right, guys, is it clear up to there? Everything is fine with the VPC, PVC, and the STP part?
Can't we have a practical instead of going to the section 2? We can have a practical section to cover up this the section on top.
Yeah. So
Because
for
by the
that,
time when we reach to the section 5, like there will be so much of theories which I will not be able to recall it during the time of practical.
okay, that's fine. But Abbas, we have to go with the syllabus scenario of your decode. So I cannot ignore all the three, four sections for the same. Like we have pending with the four sections. So after the fourth section, there is a fifth section for the data center overlay protocol. At that moment, you will be having the lab scenarios in which you will be going to perform the configurations and all. But before that, these topics would be clear to everyone so that it will be more useful and benefited to you also. Because understand about the VPCs today. Yesterday we have covered STP, right? So these switches, routers, if you don't know how you can implement the routing in the data center, right? With the OSPF version 2, 3 border gateway protocols, then you are
No,
not able to
we will
perform that.
combine it by that time when we reach to the routing protocol. We will combine the things what we are learning. But my concern is like we are learning VPC, right?
Mhm.
Honestly, like the theoretical part, it goes down for me. I need to go through the recordings again. But if we do the practical, so that for me it will be more clear.
Okay, all right, that's fine. But I have to check with the team first. Like, can we switch to the section number 5? Because see, if I jump to the section number 5 instantly, many things will be not clear to you. So for that, you can refer your own theoretical part or something related to it. So I have no problem in like summarizing the things. Okay, I can do this decode training in 5 days also, 2 days, 3 days also, in order to cover up all the things. But we have to spare time for learning part. No worries, if you are demanding for this one, I can look into the consideration about, and we can explore the section number 5.
My concern is not like to jump to the section 5. The point
Mhm.
is if we are covering one point, like we have covered the VPC, STP, so we should do the practical along sidewise, so that the questions will come up and we will have more clear visibility. Since by the time we will reach to the section 5 and then we will start the practical sessions, again I have to go through the recordings. I have to look for what we have learned.
Yeah, okay, that is your question. I got it. So, Bas, what is my answer for this? See, you don't have any labs according to your decor environment for VPCs and port channels. For section number 1 to section number 4, you don't have any labs. You have to just only go through with the implementation and the overviewing part. After the fifth section, you will be having the labs for the decor.
Okay.
Okay. So this is my answer for it, and you can check in the from the Cisco official website also. When you are seeking that syllabus part, you will be able to see the overview detailing for it. After that, you will be having the labs with the overlay protocol, zoning, ACI fabric. So these comes afterwards. Okay, all right. So let's explore in this next section related to the first hope redundancy protocol, that is your HSRP and the VRRP. But yes, I can think for that one also, Bas. I will be performing the lab scenarios parallelly from the next section, right? So we can configure the lab directly for the VXLAN so that you will become more comfortable according to your syllabus what we are learning into. All right.
Okay. Thank you.
Okay, welcome. So yes, Rakesh, any doubt up to there? Everything is clear. So shall we wind up the call for today now?
Yes, ma'am, but I want to just little bit more information, like in packet level. Like, because I know
Yes.
actually now I am working last 2 years in data center. Okay, now
Okay.
I know the concepts, how we can configure. In commands, I know the everything. But in
Okay.
the depth and the packet level, what's happened and which packets come for what reason, these information I want to grab.
Okay.
Yeah,
That's
my
fine.
concern is the same thing that we
Okay,
need
no
to go into
problem.
the depth
Yeah,
so that we
actually,
can open the debug.
yeah, I understood your concern, guys. But the thing, like for this training, every participant has joined. They want to learn from the scratch, right? So we can't ignore all of the participants, right? We can jump to the section number 5 instead. We can jump to the section number 10, 12 instantly. There is no thing which we can ignore it. So yes, I agree with you. Like, you are familiar with the things, you know each and everything related to it. You want to deep dive into the details, but we can't ignore the syllabus. We can't ignore the other participants as well, right? So we have to go with the flow according to the syllabus scenario. What we have in the decode, what you have is for. I understand your concerns. So, but you have to attend the full sections, full detailing for it. Only then you'll get more familiar ideas. But yes, from next onwards, what I can summarize, we will be performing one lab for the each section, like each session, right? So you will also become comfortable. If it is high level, the other participants will look into. If it is the low level, then the other participants can refer to the content which we are delivering. So we can mix up the things like this way according to your demand. All right.
Okay, ma'am.
Okay. So I think this could be the better option, right? All right. So let's wind up the call for now. All right. So let's connect next weekend. Meanwhile, you just take care of yourself, Abbas and Rakesh. Thanks for attending the session for today.
Thank you.
All right. Take care
Thank
of
you.
yourself. Bye bye, guys. Take care.
Okay, take care.